Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about Leetcode question number 235. Lowest common ancestor of a binary search tree. Given a binary search tree, find the lowest common ancestor node of two given nodes in the PST. So what is meant by lowest common ancestor? The lowest common ancestor is defined between two nodes P and Q as the lowest node in P that has both P and Q as the descendant. Okay, where we allow a node to be a descendant of itself. So they are saying that for two nodes, there will be a common ancestor. For the ancestor, these two nodes will be the descendant. Okay, let us understand by taking some examples. See here, if we have P is equal to 0 and Q is equal to pi. Okay, where is 0? 0 is here. Where is pi? Pi is here. Okay, now, note here, what are the common ancestor for this 0 to pi? I can say this 2 is common ancestor, this 6 is common ancestor. Okay, perfect. But what is the lowest common ancestor I can say? So this is the lowest common ancestor I can say, right? This 2. Because from this 2 only, this 0 is splitter and this 5 is splitter. Can you understand this? Can you understand this? So in another way, we can say it like what? In particular node, this both P and Q will be splitter. Okay, fine. So I can say this answer is what? 2. So what is the answer for this P and Q? It is 2. Okay, fine. Now let us understand by taking P is 2 and Q is 7. Okay, where is 2? 2 is here. Where is 7? 7 is here. Now for this, what is it? Lowest common ancestor. I can say the lowest common ancestor is this. So this is the lowest common ancestor, right? So because see here, the 6 splits both 2 and also 7, right? So I can say my lowest common ancestor is 6. Okay, fine. Then P is equal to 6 and Q is equal to 7. Now where is 6? 6 is here and where is 7? 7 is here. So this is a whole different example. Let us understand this. See here, for this 7, the 6 is ancestor, and for this 6, this 6 is itself an ancestor. So I can say this both have a lowest common ancestor of what? 6. So what's my output? My output is 6. That's it. Hope you understand this, right? Now, what is the lowest common ancestor in our definition? It is something like node that has one PRQ value in our left subtree and one PRQ value in our right subtree. So this is what gonna be like our lowest common ancestor. So this is our LCU. Hope you understand this, right? Now let us take this example. Okay. So what is a brute force approach? Okay, the brute force approach is something like we want to take the path. Okay, we want to take the path. Okay, let us take P value as what? P value is 0 and Q value is pi. Okay, now from this root to this 0, I can say this is a path. Yes, and from this root and to this Q, what is the path? It is to this 5, right? So this is the path. Okay, let us write here 6 to 0. 6 to 4, 5. Now tell me whether the 6 and 6 are same. Yes, same. Whether this 2 and 2 are same. Yes, same. Whether 0 and 4 are same. No. Then I can say that before 2 is the answer. So 2 is the answer. So 2 is the output. See here, 2 is the output. Hope you understand this, right? So this is a simple brute force approach. So what is the time constant? I can say time constant will be O of let's just take number of nodes n, then O of n, because we are now seeing it's a every node, right? And what is space constant? I can say we are taking the auxiliary space, which is a array. So it will be what? O of n, right? So this is the dynamic space analysis. Now to optimize it, we can use lowest common ancestor in a binary tree approach. We can use a lowest common ancestor in a binary tree approach, in which we will return the each and every node value like this in previous video I have told you, right? So if you haven't seen this Leetcode number 236, just go and watch it. Okay, in this approach, first I will tell the brute force, then I will tell how to find the lowest common ancestor in a binary tree. Okay, so after watching it, just continue. I will give the link in the description. Okay, so this is the code. Okay, fine. Now let us continue with this. Okay, so this is a quite optimization. What is the time complexity? I can say time complexity will go up here. and space of the will be O at Z. So this is quite optimized. Okay. Still, I want to optimize the solution. How can I do it? So if I ask you, still an optimized solution. Okay. First of all, we want to know what is a property of binary search tree. So I can say for each and every node, the root value should be greater than the left sub tree. Left sub tree entire value, and also the root value should be less than that of the right sub tree entire value. So this is the main property of binary search tree, right? This is the main property of binary search tree. Okay. Now, what is the definition of LCU we have currently discovered? So it is like from which there is a split occurs. Say if it is 0 and 4, here from this 2 only the split occurs, right? If it is 0 and 5, this 2 only the split occurs. If it is 0 and this 9, the 6 only the split occurs, right? Right? So from this, I can say by combining this 2, I can come with a solution like if I have a split, then one value should be less than the root and another value should be the greater than the root. Other than that, we want to go with the long side. Okay, let us understand what I mean. So let's take P as 0 and Q as 5. Okay, initially I have the 6, right? Initially I have the 6. Okay, I'm checking whether this 2 value is greater than the 6. No, this 2 value is less than the 6. Yes, it is less than the 6, which means what? This 2 value will be in this subtree. So we can neglect this subtree. We don't want to iterate to the right subtree. So I eliminated the half. So this is the optimized way, right? Okay, let us go down. Now it is what? 2. Okay. So for this 2, whether this 2 value is less than the 2, no. Whether it is greater than the 2, no. But 1 is less than the 2, another one is greater than the 2. That means what? 1 should be in my left subtree, 1 should be in my right subtree. So I can say this 2 is my answer. So I will written what? 2 as our output. Can you understand this? Okay. So how my code looks like? My code looks like something like I should iterate up to my root become null. And if my p value is greater than my root value and my q value is also greater than my root value, then what should I do? It means like both p and q are greater than the root value. They both will be lying in the right side. So I will update my root as what? Go to the right side. That's it. Okay. LN. This both p and q are less than the root's value. Then what should I do? I just go to the left side because there is a possibility of these two nodes in the left side, right? So I will go to the left side. Okay. Else, what should I do? Else means what? The both are in the one part and another subtree. So at that time, I will return that node. I will return that root. Okay. After finishing this entire thing. So this is what my entire code looks like, right? So this only 4 to 5 lines of code. So what is the time and space complexity for this code? I can say my time complexity want to be O of height of the screen. Why? Because we are just going to the depth. Only by utmost we can go to the longest depth. Apart from that, we don't go. Right? We are eliminating each and every time. So it can be sometimes equal to a log n also. It means what? A log n in a complete binary or like that. If it is a balanced tree like that, there will be a log n. But in approximately, it is what? O of x. Okay. What is space complexity? It is O of 1 because we haven't used any extra auxiliary space. So it is super optimized, right? Yes. So we are just done what? Binary search tree property plus what is our question states. So these two is the combination of this solution. Can you understand this? Okay. Let us understand the solution. See here. The same code I just written here also. Okay. See here. If P's and Q's value is less than the root value, then I move to the left. If P's and Q's value is greater than the root, I want to move to the right. And if it is not so, then I will get the root. That's it. And I want to do this up to what? Up to while this root. While I having this root. So it is like we will conformly find in this loop itself. So if I take this as while true, it is also not false. Okay. Let me submit it. Yes, it is submitted fully. Thank you. Okay.
And the other hand, dad, no.
Yes, so the name is